delighted to be with you this afternoon. We know that a number of friends, family, community, church family members are here during Family Connect. Now, for those of you who may be new to Bethany's Family Connect, we're here every a Sabbath or Saturday afternoon at 4 p.m. And we're here to connect with each other. We know this time away from the church has been extremely challenging for all of us. So this is just an opportunity for us to use technology and to connect. Not only are we here every Saturday or Sabbath afternoon at 4 p.m., we're also connected together every evening at 7:15. And that's a time that we come together, call, and we have prayer together at 7:15 each evening. So at the end of this program, our pastor will come and he will give you additional information on that call should you decide to join us at 7:15 p.m. each evening. We're delighted to be with you. For those of you who may not know us, my name is Kirk Nooks, and my wife is Nelson Nooks. We serve as family life directors at Bethany Seventh-day Adventist Church in Macon, Georgia.
I don't know who this man is.
Edna Place. We're going to ask everyone to remember that this is being streamed live. So hopefully those of you who are watching via YouTube, we want to welcome you to this program as well. Well, this program tonight is going to be focusing on the COVID-19 vaccine and what you need to know. We have three panelists who will be coming to you in their own way in just a moment to share and respond to questions we've already prepared and we've already asked them. But that does not mean that at the end of their presentations, you cannot ask questions. We're going to ask for those of you who may be on Zoom to identify or locate the chat function. You can be putting in your questions at the chat function. Allison will be monitoring that, so we will have your questions at the time the presentation, the formal presentation, is completed. We're here to talk about COVID-19 this evening, and based on the Johns Hopkins website that tracks all of the data that many of us routinely go to, we know globally, there's been 89 million cases of COVID. Over 89 million cases of COVID. Unfortunately, globally, 1.9 deaths, 1.9 million deaths. Here in the United States, we've had over 21 million cases of COVID confirmed. And many of us have watched the news to know that of those 21 million, we have realized that 370,119 people have passed away due to complications from the COVID-19 virus. So this is something that is touching each of us. We know within the past several weeks, we have heard of even pastors who have passed away or other loved ones. So this is serious. This is touching all of us in our own individual lives. And we want to know more about this vaccine that is now on the scene that's probably designed to help, if you want to call it, help us to be protected from this terrible and challenging virus. We do want to say at the very beginning of this onset of this program is not to sway you to take the vaccine or not take the vaccine. We're looking at this as an educational opportunity to hear facts concerning the vaccine and that you will make your own decision. So again, this church is not advocating one position or the other. We're not telling you to take the vaccine or not to take the vaccine. This is an opportunity for us to come together and hear more about the vaccine and become educated about it. So at this time, we have three panelists, and Allison will introduce each of our panelists this evening.
All righty. Good evening, everyone, or afternoon. We'd like to welcome Dr. Holness, Kenworth Holness, which is actually one of our members. He was born in Chicago, Illinois, attended Andrews University, got a degree in biochemistry, and went on to Loyola Stritch School of Medicine. He also was at Rockford Memorial Hospital in obstetrics, had a fellowship there, and served in medical missionary in Kingston, Jamaica for the General Conference of Seventh-day Adventists. He currently works at the VA in Dublin, Georgia, and he is married to his lovely wife, and they have 4 children. We'd also like to welcome Andrew Reed. He is an epidemiologist for the Tennessee Department of Health, where he is a data quality regional lead working on the COVID-19 control program. He was a data manager at Tennessee State University, where he worked with researchers to identify best practices to keep students in the STEM pipeline. He is a graduate of Oakwood University. He graduated in 2009 with a BS in biomedical sciences. He's also a graduate of Georgia State University, where he received his Master's of Science degree in biology. Andrew is a dedicated young investigator and has participated in numerous research projects. While at Georgia State University, Andrew spent time at the Centers for Disease and Control and Prevention, which is the CDC, where he worked under the mentorship of Dr. Jason Ahazia. He worked in the Division of Population Health, where he learned about various sampling techniques and conducted trend analysis on declining prevalence of smoking. He also worked with Dr. Eric Gilbert at GSU in the Department of Applied Environmental Microbiology, where he honed his microbiology skills and assessed the use of benchtop bioreactors for the use of industrial microbial growth. He completed an internship at the Defense Forensic Science Center, where he worked for Dr. Roman Aranda to determine how degraded DNA can be used to generate DNA profiles. Whenever Andrew finds a little free time, he spends his time with his wife, as well as he can be found tinkering with electronics or practicing on his bass. Andrew plans to further his education by pursuing a doctorate in biostatistics.
Our final panelist is Thesakar Antone Reed, Dr. Reed, that is. She is assistant professor and medical director of microbiology and immunology. She is currently working at the Metro Health Medical Center in Cleveland, Ohio, as a clinical pathologist with a specialty in clinical microbiology and immunology. During COVID-19, she's been serving, of course, as I mentioned, as a clinical pathologist, and she is in charge of the COVID-19 testing in the laboratory. She assisted the hospital in making policy surrounding testing algorithms for patients and determines the clinical appropriateness of testing platforms for infected patients. When you ask her about COVID-19, she mentions that it's taught her a new level of dedication to her job. Says in the beginning, she worked nonstop to provide testing, and she's never worked as hard in her life. It's propelled her in a way to really think about what life can be like in a very short period of time. As a medical director of the laboratory, she's called to make a lot of tough decisions around testing, but once again, it's helped her to become more of a confident leader. So with all of that, we present to you three individuals who are going to share with you some thoughts. I'm going to ask them the questions just to sort of kick off. And of course, they will in turn come to you. I know they have presentations that they'd like to share. We're going to go ahead and start with Dr. Holness. Dr. Holness, you know, we previously provided you with some questions to get started. Can you kind of explain what the COVID-19 virus is all about, how it's transmitted, or what do we need to understand about the COVID-19 virus versus the flu? And then what has been the impact on the hospital setting on a daily basis based on what you've seen? Dr. Holness, you're on mute.
Can you hear me now?
Yes.
Oh, okay, good. I want to thank you for having me and having the others and having this forum. This is such a very important topic, especially in the time of now that we're all looking at the vaccine, and this disease has hit us since March of last year. Miss seeing you guys at church, and it's good to meet some new colleagues from the CDC and the other colleagues from Cleveland. I'm just going to start with some basics because, as you know, with this disease, we're learning more and more each and every day. So just some basics. We're looking at the coronavirus, SARS-CoV-2. This comes from the coronavirus family. There are three viruses that have come over the years, over the past couple of decades, that we've been exposed to. The first one was SARS-CoV-1, which was in 2003, and then MERS, which was in 2012. SARS, let's look at SARS. So SARS stands for a respiratory syndrome, is subacute, a severe acute respiratory syndrome. And when you think of a virus, one of the things my wife says, she's a microbiologist, you have to remember that the virus needs a host. It needs something to live in order for it to replicate and to continue to live. This is a viral illness, and this illness can spread from person to person. Some of the things, they're still learning a lot about this virus. They still don't know where the virus actually came from. They're thinking over the past 40 to 7 years, it's been developing. And so it's interesting how it's considered a novel virus. It's a very new virus. And so that's what makes this virus so, so interesting and so difficult to treat, because we've never really seen anything like this before. And we've never had a vaccine for this type of a viral infection. Even with the SARS-CoV-1 and with the MERS, they've never developed a vaccine. And I'm sure my colleagues are going to discuss more about the vaccine, but vaccines in general usually take about 10 to 20 years to develop. And so people are wondering, how were they be able to develop this so fast? We're going to get into that. It was first identified in Wuhan, China in December 2019. When you look on how viruses are transmitted, many people are thinking, and researchers are thinking, that it may have started with in wet markets. These are markets where things are sold, live animals are sold, and so they're thinking the virus could have started in such like a bat. That could have been one of the hosts or reservoirs, or a pangolin is another mammal, and that could have transferred it to animals, such as a cow, such as cattle, such as a camel, such as rodents, and that could have transferred it to humans. So those are some of the things we look at, and those are important concepts. Let me just get with the talking about just some of the symptoms. Some of the symptoms we look at are respiratory symptoms such as coughing, sneezing, even personal contact. So respiratory droplets is how it's spread. The virus gets into our lungs, it proliferates, or it multiplies in the lungs, it gets into our respiratory droplets, and we cough. There was a study I was looking at just during this whole pandemic, and they were talking about how far and how fast people cough. Coughing can be up to 70, 80, 90 miles, I think they were saying, and you can cough pretty far. And so the whole idea of social distancing, 6 feet, and now I think they're talking about 12 feet distance, because of people coughing and how far they can cough. There was another study that showed the experience I'm sure you guys have heard of in Seattle. I think it was Seattle or Washington State, where they had the choir that was infected. I think there were about 50 members, 40 to 50 members of the choir, and 32 of them were infected, and I think maybe 1 or 2 may have died. But the whole idea, it was a choir, it was a contained room, of course, church. They were singing. They didn't know that they had the virus. And so that's another concept with the virus, is that it spreads in an asymptomatic state over the next, within a 3 to 5 to 7 to 10 days. You may not have any symptoms, and you don't know you have any symptoms, and that's what makes it so lethal. You don't have any symptoms, but you could be spreading it to other people and not realize it. So in this church, they were They didn't know that they were infected. They still don't know how many people were actually infected. But with the singing and the shouting and the singing, they were able to, the infection spread in that contained church. And I think 32 members, if I remember correctly, ended up sick, and I think one may have died. So that's how lethal this thing is. They're also talking about, I know my colleagues will also talk about the variant, that the variant may be more transmissible, not necessarily more deadly, but maybe more contagious and transmissible. Just a couple of more things. I know they have slide presentations. I'm sorry, I didn't bring my slide presentation, but I'll make sure I comment on their slide presentation, but I'll leave the slides to them. Just a couple more comments. You brought up about the VA. I work for the VA, been working for the VA since 2004. This virus has changed our life, not only in the general population, it's changed medicine. And it caused you to think, and it caused me to think, and a lot of us physicians to think, why did I enter medicine? And I figured out why during this pandemic. I like taking care of people. During the initial part of the pandemic in March, when now a lot of research now are saying that it started probably in December, November of the year before in 2019. I have a sister that said that she was sick, and I have another physician colleague who was sick in December, and a lot of them presented with these flu-like symptoms, and they weren't sure what they were. So we know it was probably here much sooner. But the whole concept is that these symptoms that you have to try to monitor yourself. And so working for the VA, there have been many changes, and that's the thing. Being in the VA, being in medicine, I would have never thought that I would be in the middle of a major global pandemic. And we go back in history with smallpox, and 300 million people died. We go back with the Spanish flu. The Spanish flu, they're saying 50 million, maybe up to 100 million people may have died. We look at cholera, we look at polio, we look at all these different things that we have, pandemics and epidemics that we've been involved with. And so medicine has changed in a positive way, but in a negative way, to see that we're experiencing this. I go back to 2018. 2018 was celebrating the 100th year anniversary of the pandemic, of the flu, the influenza, the Spanish flu pandemic. And during that year, usually on average, influenza A and B, influenza in general, we would usually have about 30 to 40,000 fatalities. 20 to 40,000 would die each year. And in that year, in 2018, there were about 80,000, I think, roughly numbers of people. So it doubled. And interesting, that happened during the time that we were celebrating it's the 100th year anniversary for the Spanish flu pandemic. I say that to say that in general, with respect to the numbers of influenza, we usually only vaccinate 45%. And I know my colleagues will bring up more of that too, but just throwing out that number. But in the VA, it has changed. We've had to go through seeing patients face-to-face to video. It's actually pushed video connect. It's actually pushed more telephone visits. Our hospital, we actually shut down for a couple of months, 2-3 months. We reopened phase 1 in June, the middle of June. We opened phase 2, I think, in September. And now we're shutting down again, where we're only going to do telephone visits and videos. It's actually a good thing because it increases access, but there are some patients that do need to be seen face to face. Last thing about the virus is that they talk about phases and spikes. We have seen that now we're in another phase or another wave with respect to Thanksgiving and Christmas and New Year's, and we can only expect for it to get worse before it gets better. So hopefully the vaccine is a tool. Hopefully it can help. But even with the vaccine, we still need to practice the things that the CDC has been talking about. That is, social distancing. That is definitely making sure we're washing our hands on a regular basis, and watching our temperatures. Not, if you're sick, not going to school, not going to church, not going to work, and monitoring ourselves on a regular basis. So that's the closing of my, hope I answered all the questions in the way you wanted me, Dr. Nooks. And
Thank you so
I look
much.
forward to the other presenters.
Thank you so much, Dr. Holness. So you've heard so far of how COVID-19 came to be. Some of the theories evolve around the wet market over in China. It spread rapidly. This is not the first time we have faced a global pandemic. I think Dr. Holness mentioned the Spanish flu and others. But now we also get into the time of hopeful recovery, and that stems from a vaccine. We know that vaccines are not new. They're not anything that's just been around recently, but many of us have taken vaccines for various reasons. So Dr. Fesekar Reed, we're going to ask you to come to us next. There's been so much conversation about the vaccine, the FDA approval process. Can you talk us through some of that? Can you talk to us about the difference between the vaccines, some of the reactions to the vaccines, and the efficacy and the safety of the vaccines? Can you come to us in your own way now and kind of just walk us through some of that information?
Yeah, absolutely. So before I talk about the vaccine, I'm just going to talk a little bit more about the virus so we can understand how the vaccine works. So it's interesting because like my actual background is in virology, and a part of my dissertation looked at nanoparticles. So when we talk about viruses, we know that viruses, like my colleague said, a virus needs a host. And a virus really cannot enter until it has full access. And the way that it gets access is through binding to receptors on our cells. So think about your cell as a wall, and it's trying to prevent invaders from coming in. So these are bacteria, funguses, viruses. It's protecting your body against these invaders. But the key thing about viruses is that they have a way to navigate our immune system so they can go undetected and enter. And the way that they do this is through receptor binding. So think of your cell as a door, which has a keyhole. And think of the virus as having many different keys. And it continues to try different keys until finally it hits the right receptor and it gains access. And so now your body is susceptible to allowing the virus to enter and basically using your cell as its own replication machinery. And so this is kind of where we see the viruses kind of coming in, taking over, being able to spread rapidly because they have this mechanism of binding to your cell receptor, gaining access, and using it to replicate and spread. So when it comes to the vaccination now, they actually used a really cool method, which I think is really impressive and is actually quite novel. So most of the vaccinations that we've had before, they're DNA viruses, they're DNA vaccinations. But in this vaccination, what we have is an mRNA vaccination. And as a delivery vehicle, they combine it with a nanoparticle. And so in all vaccinations, we know that the goal is to help your body to fight. And so by delivering the vaccine to you, we can increase the chances of your body developing antibodies to fight against the infection. So that's the whole goal of vaccination. We may not be able to fully stop infection, but in case you encounter it, we want to give your body a fighting chance to have a defense mechanism against infections. And this is why we vaccinate our children. This is why we vaccinate the elderly. This is why we vaccinate people who are at risk, because we want to give them a fighting chance in case they encounter the infection to be able to defend themselves. So when we think about the vaccination process by the FDA, it is a very long process. But normally the vaccination process is much shorter because it's not much longer because it's not an emergency. So in this case, in the case of a global pandemic, instead of going through the 10, 20-year process that the FDA normally goes through, the FDA utilized another mechanism known as the emergency use authorization process. And so this is the process that whenever there is a pandemic and there are not available tools on the market to help the population to have a defense, the FDA uses this as a way to basically get the products to the population to making sure that the benefits outweigh the risk. So, and as I speak to you about this EUA process, the two things I want you to remember are benefit and risk. And this is how the scientists that review the data view it before they put it on the market. So I'm just gonna pull up the FDA EUA process, some like salient points to help you get a better understanding of how is it that it got to the market so fast.
As Dr. Reed pulls up her PowerPoint, we want to remind those of you on Zoom, you can look in your upper right-hand corner. You can click on speaker view and it will open up the screen just a bit larger. For those of you who may be on Zoom, you may be on gallery view and you're seeing everyone. You can go to your upper right-hand corner, click on speaker view, and then it will take over the entire screen of your computer.
So whenever the FDA says we're gonna allow a vaccine to come to the market, it uses various safety systems. Just because the truth is, as in any foreign molecule that we introduce, there can be a possible adverse effect to getting a vaccination. And so the FDA is very diligent in making sure that they can monitor if there's anything that happens, they can report it. And so they have these different systems, the vaccine adverse events reporting system. So in the case if, let's say, a child got a varicella or the chickenpox vaccine and then ended up getting chickenpox, their primary care physician would report it. There's also the vaccine safety data link, the biological effectiveness and safety initiative, and then the Medicare claims data. And basically these are different systems that the FDA is constantly monitoring to make sure that individuals that get vaccinated, if there are any adverse events, they're able to record them. And so making sure, again, that the risks do not outweigh the benefits. So what happens in the actual EUA process? So basically during times of pandemic, the FDA utilizes this process known as the emergency use authorization. And basically it grants the ability to use medical countermeasures, such as a vaccination in this case, during a public health emergency such as the COVID-19. And under the EUA, the FDA permits the use of products that have not undergone the regular FDA approval process, which is that 10 to 20-year process. And basically, the reason that they do this is because there's currently no adequate, no approved, or no available alternative. And basically, if the government sees that this is something that they really, really need, they want to make sure that they're not putting out a product that is not safe and isn't up to the quality standards of the FDA. So each product that comes to the market must still undergo the same stringent process that the FDA would require, but under its emergency use. So let's say I have a drug that I want to submit to the FDA for emergency use authorization. Just because I submit it, does that mean every single drug is going to be approved? And the answer is actually no. So each product must undergo a very thorough investigation. And the investigators include scientists from all over the world and different agencies of the government that look at the actual scientific data to make sure that it is up to the standard and par to the FDA. So what exactly are these components that they're going to look at? And I wanted to make sure I put all of them that are a part of the application so we can get a good idea of what happens. So the first thing they look at is the vaccine composition. So what is in the vaccine? Are there any things that are in it that individuals with allergies are going to have a side effect to? What's in it? What is the actual dosing regime? So does it require 1 dose? Does it require 2 dose? What happened during the clinical trial phase 1? So for all vaccinations, just because it came out quick doesn't mean that it skips the clinical trials. It still had to go through phase 1, phase 2, and phase 3. And so in the phase 1 trial, which is a very small trial where we use a small amount of people to confirm that the actual dose is adequate, we want to make sure that this was safe, that this dosage worked, that it gave us the type of immune response that we need in individuals for them to fight the infection. The next thing they do is they look at the actual study and experimental design. So is the study scientifically sound? Is it biased? Is it properly controlled? So making sure that the science will match with the outcome that leads to something that can be on the market. Then they look at what actually happens in phase 2 and phase 3. So basically phase 2 and phase 3 is when we expand the trials to include hundreds and thousands of individuals. Next thing they look at is subject disposition and inclusion. So did we include individuals from all ages, races, sexes, gender, health conditions? Have we covered all those things? The next thing they look at is the demographic and baseline characteristics. Where are these people located? Are they in high risk or low risk areas? They look at the vaccine efficacy. Also, most importantly, the safety. So what risks are going to be associated if individuals get this vaccination? And then next, they look at the effects of the blinded group versus your group that was placebo. So were you actually able to follow up with both groups of people, those that actually got the real vaccination and those that just got the placebo vaccination? And were we able to actually have a fair comparison to both? Next thing they look at is drug safety. So basically monitoring after we give the vaccination to each person, what happens to them? Like, what are some of the side effects? Are they experiencing the same side effects, or does it affect one person differently than the other, or one group more than the other? Next is the chemistry. So if we bring this vaccination to market, how will we actually manufacture it? Is it something that is sustainable? Is it something that is stable? How can we store it? How will it be administered? Who will administer it? All of these things have to be considered before the vaccine gets its EUA approval. Next is the developmental control. So how are you going to keep it stable? So do you need to put it in a freezer? Can it be left out in a fridge? Can it be left at room temperature? How stable is this going to be at different temperatures? Next is going to be your clinical assay and inspection. So does the drug even meet the standard code for usage? So before any drug is put to market, there has to be a certain code and standard that it meets. And lastly, again, what I want you guys to remember, risk and benefits. Throughout the history of vaccinations, things have been released where they look at the risk and the benefits. And the moment that the benefits outweigh the risk, the FDA says we're going to pull it back. But in this moment, the benefits far more outweigh the risk. And later I'll go through some of the adverse events that people have experienced with vaccinations. But again, a large group of scientists look at the risk and the benefits. And when the benefits outweigh the risk, they say, yes, this is a product that we can use. Are there any unknown benefits? So in your study, was there something that you came across that you didn't think was a benefit, but was a benefit? And lastly, as all scientists have to do, you have to be unbiased and really look at the gaps in the data. So while you do, any product is going to be put out there to make sure it is safe for your patients to use, there's also going to be questions that we just can't answer just because we just don't have the time yet. So what are those data gaps? And if those gaps, again, outweigh the benefits, it might not be something that we want to expose the population to. And lastly, unknown risks. So are there any unknown incidental effects that happen when people get vaccinated? So how was this vaccine developed so quickly? One, it went through the EUA process, but this was a global project that happened. It wasn't something that was just developed here in the US. It was something that required people from all sorts of agencies working together to prioritize and strategize a speedy development of a promising vaccine. So individuals that worked on this, we had government agencies, we had international counterparts, we had people in academic institutions all over the world working on a vaccine, we had people at nonprofit organizations trying to develop ways to vaccinate, we had people at for-profit organizations, and we also had pharmaceutical companies. And so initially there were over 120 vaccines that people were actually working on, but honestly, out of all the 120, only 3 were able to meet the safety and quality efficacy criteria that required FDA or EU approval. So you have the Pfizer vaccine, the Moderna vaccine, and the AstraZeneca. Okay, so what are some of the main differences that we see between the Pfizer and Moderna? So like I said before, both of them are going to be your mRNA vaccinations. So they're going to introduce your body to a piece of mRNA from the viral spike protein. And when your body sees this, it's not going to think it's the actual virus, because it's not, but it's going to develop antibodies against it. So they both are very similar in that regards. However, when it comes to Pfizer, the age where it's been approved is a little lower. So Pfizer, it can be administered from ages 16 and older, while in Moderna, the age of administration is going to be 18 or older. Pfizer is 1% more effective, so it has an efficacy of 95%. And when we say efficacy, meaning of the Pfizer, I believe they had 30,000 patients enrolled in their study. So of the 30,000 patients that were enrolled, it was effective in giving 95% of the people antibodies to fight infection, while Moderna was 94% effective. They both have reduced risk of the severe COVID disease. And when we say severe, the severe risk, so we're talking about, all the images that you've seen on CNN where individuals are intubated, where they have severe cardiac and pulmonary diseases. So these are the risks that we're trying to mitigate in the population. And this is what the vaccine is helping your body to build antibodies to fight against that. When it comes to Pfizer, it is a lower dose vaccination. So the Pfizer is a 30 microgram dose, while Moderna is 100. So it's a 70 cc's more than your Pfizer. And then lastly is the 2-dose step. So with the Pfizer, you get your second dose 21 days after the first day, but Moderna, you get it 28 days. So there's a little difference again in the time that the different vaccinations need to help boost your immune system. So what are some of the side effects? And I classified this with milder and more severe, and then I'm also going to slightly take time to address one side effect that has been circulating on WhatsApp. But the milder side effects are going to be injection site pain. A lot of people experience that. There's fatigue, there's headache, muscle pain, and joint pain. So these are just some of the milder symptoms that you get. And if you've ever had a vaccination, you've experienced these. Some of the more severe side effects are going to be your difficulty in breathing, swelling in the face or throat, increased heart rate, rash all over your body, and dizziness. One side effect that has been circulating that I've seen the video of is Bell's palsy. And so in both the Moderna and Bell's palsy, for those that may not be familiar with, is when you have kind of a lack of muscle movement on one side of the face. And when I looked at the studies for both Moderna and Pfizer, so for Moderna, they used 43,000 patients. And of 43,000 patients that were treated, 3 of them experienced Bell palsy. And that's like 0.00006%. For Pfizer, of their 30,000 individuals, 4 people experienced it. And so that gives you a percentage of 0.0001%. So while this is something that we see often in media, the chances of actually experiencing this side effect is extremely low. But again, our FDA has done due diligence. So whenever these side effects or symptoms come up, they have databases to keep record, again, to make sure the risks are not outweighing the benefits. So who should consult with your doctor? One, if you're immunocompromised. So the trials only included like a certain amount of conditions such as HIV, HCV, HBV, and some other ones. But if you are someone who is immunocompromised, someone who takes blood thinners and specific medications, I would strongly advise you, and I'm sure my other colleagues would as well, to talk to your doctor about whether you should take the vaccination. Individuals who have known allergies to vaccinations or components of the vaccination. Again, this is something that you should consult with your doctor about because you do not want to have an adverse effect if you already know you have allergic reactions to vaccinations. And lastly, pregnant and breastfeeding women. Initially, the trials were not done in women who were pregnant or breastfeeding. And so again, to take these, it would just require you to have that conversation with your clinician to make sure it's in your best interest to get this vaccination. I think that's all I have.
Just to add what she said, so the 94% and the 95% efficacy has to do with 2 doses, not just 1. So I'm sure she was going to mention that. So that's key. And then I'll talk about later on about comorbidities and everything like that. But yeah, thank you very much for that presentation.
Thank you so much, Dr. Reed. At this time, we're also going to now ask Andrew Reed if he can come forward as he's bringing up his PowerPoint. We're hearing about a new strain that's possibly circulating. What does that mean for individuals? Can you talk to us about the possible timing to get this vaccination for those who may be interested? And can you share any other information? So please come to us at this time in your own way. And you would need to unmute.
Okay, thank you. I guess we'll start with the mutation. So we heard in the news that we have the new mutations, these variants about. We have the UK variant. We also have the South African variant, and we're seeing reports that we're seeing the UK variant in different parts of the United States. And I guess kind of before we kind of go more into that and kind of what exactly that means, let's kind of go exactly into what viral mutation is. So let me share my screen. Okay, so how do viruses mutate? And then when we kind of say mutate with viruses, it's also pretty much how do they evolve? And it's pretty much their need for survival. So, and it doesn't necessarily sound as bad when you say viruses mutate. It's just because that's just part of how they operate. But there are times there where when a mutation happens, it can be a minor mutation where nothing happens, or it can be something where something, adverse happens. So how do they mutate? So we have bad proofreading. That's what you see in viruses. And then this kind of goes to the testament of how God created our bodies and how well he did it. So when we undergo DNA replication of the cells, we have 2 strands of DNA that gets replicated. And then that's kind of like a protective measure. And then also in addition to that, there's also a proofreading mechanism. So it's kind of like playing the whisper game. So if you start out, God created the heavens and the earth, somehow you're going to end up with God created space and earth. So there's a little change up in there, but then sometimes you can get God created, Jesus wept. So so I know it's kind of extreme, but you kind of see some of the stuff that was just kind of spontaneous, just like that. So that's kind of how viruses happen. So especially with RNA viruses, they don't have a proofreading mechanism. So that's kind of where you can see some of these mutations. So then also, how can they mutate? There's also different external factors that cause them to mutate. So like different medications, even vaccines too, and then also the environment too, it causes viruses to respond in a way. So as was mentioned before, a virus is not alive and it needs the host system to survive. It is not in a virus's best interest to kill off its host, because if it gets killed off, if the host dies, it dies. So if there's a bunch of hosts dying because of the virus, mutations are going to occur. So it's like, okay, let's tweak this so that way we don't cause death, but we can like keep going on, like so we can keep going on. And then we also then kind of look at which viruses generally mutate quicker, and we see that in our RNA viruses. And then we kind of give you a sense, so we kind of have like RNA viruses and DNA viruses. So like RNA viruses, you kind of see one mutation every about 10,000 nucleotides. And nucleotides are pretty much, we call them the building blocks of life. The 4 letters we all learn that kind of make up like our DNA and mRNA, we kind of say this is exactly how an organism is supposed to be. So RNA, you'll see one mutation every 10,000 nucleotides. Whereas in DNA now, you're going to see one mutation in maybe about 100,000 nucleotides up to 10 million nucleotides. So you have this huge gap in DNA where it can make these copies without any mutations, but where you see in RNA, you're going to have a lot quicker. So just based on the very nature of viruses and how they operate, they're just prone to mutations. And then what makes coronaviruses particularly interesting is that, one, they're RNA viruses, so they're predisposed to mutate. But then also, with coronaviruses, they also have a capsid gene in it. So that makes their genome more stable. So you won't see as much mutations compared to if you see, for example, like influenza. Let's see, going on. Okay, so then this kind of brings up the concept of drift. So as the virus replicates, the genes undergo random copying errors, as I mentioned before. So then we kind of see how when the virus mutates, you kind of see like something. This is normally what happens. We see our antibodies actually attached to the surface of the virus. The antibodies attached to the surface of the virus. But then when you kind of have some of these mutations, kind of what we're seeing now with some of them, they kind of prevent that antibodies attaching to it where you won't get recognition. So in this case, we kind of, we're seeing like we drift a little bit, and we kind of, and it's like, and these are kind of like subtle changes where you kind of see, it's kind of like so like somebody growing up. So you kind of see if like somebody's like, oh, this is what they look like at 10, but then 10 years later, it's like, okay, that's still the same person. So that's kind of what like when they say antigenic drift is, it's kind of like, it's not a drastic change. And then you can kind of see how with coronavirus, it mutates a lot slower than like influenza, for example. So I know a lot of people wanted to compare influenza and coronaviruses, but I guess it makes sense to kind of compare to what you know, but then you can't make a apples to apples comparison just because they operate differently. So influenza mutates 4 times faster than coronaviruses. And that's kind of the thinking when a lot of people are saying, oh, by the summer, this will be done, because we're basing this off of what we've seen in influenza viruses. But that's not the case. And we're here in winter. So, and then also just remember too, that like mutations are a sign of fitness. So the faster you mutate, the more fit you are. Okay, so, and then we also have this other concept called shift. And these are a little bit more more drastic. So I have a copy of the SARS-CoV-2 genome. So in SHIFT, you kind of get this amalgamation of genes. So let's pretend this was influenza and all these were different segments. So in SHIFT, you kind of like chop them up there, put them in a bag, shake it together there, and boom, whatever you get rearranged, that's that SHIFT. Coronavirus necessarily doesn't do that. It kind of more so goes up a recombination type of process. So you'll get like maybe one strain of coronavirus, another strain of coronavirus, it gets in the cell, and then kind of like when it goes through the replication, it's like, okay, I'll take a piece from here, and put these together, and like, and this will probably make the best thing so we can like keep on living. And then SHIFT is kind of what you see, the things that kind of make where you can get pandemics, just because they have the potential to kind of like, you can choose like if you want the best of the best for survival, but it also occurs less frequently than drift. So what does that mean? So we have like these new variants. We have the UK strain and the South African strain. And it really comes down to like their potential consequences. So they have the ability to spread more quickly in humans. Is that a good thing? Maybe. Is it a bad thing? Maybe. No one really knows for sure. We just know that we've seen some stuff that where there is increased spreading, where they can spread more between people. Do these have the ability to cause either milder or more severe disease in humans? That's another question we're not too sure about. We just know that the possibility is there, and then as we examine more people, we can actually then determine, okay, you know what, this strain, it's making people a lot sicker, they're possible more, or it's like, you know what, maybe it's not as bad as we thought. It's just the verdict isn't out yet. And then another thing to consider too is the ability to evade detection by specific diagnostic tests. So most commercial PCR tests or polymerase chain reaction tests have multiple targets to detect the virus. So did this mutation occur in, so it occurred in one of the spike proteins that allow for entry, but when vaccines are made, they kind of target a lot of different proteins. So it's not kind of like, oh, this is, if this is blocked, then oh no, like there goes the vaccine, it's no good. So it's kind of like let's do our best to kind of make something where we'll give our best shot that even if the virus does mutate, it won't necessarily be an end all be all. And then also there might be decreased susceptibility to therapeutic and antigens, and kind of going back to kind of with similar to the PCR like diagnostic test, but then the same thing like with the monoclonal antibodies. Like there's really no evidence yet that this will actually decrease the vaccine's efficacy or effectiveness. And then does this have the ability to evade vaccine-induced immunity? And the verdict is still out on that. So since the FDA, so the FDA has, when they do stuff there, they kind of make, they kind of like, okay, make this product that it won't get shut down if somebody counters it too easily. So a lot of the vaccines that are on the market, they're polyclonal producing antibodies. So they target several different parts of the spike protein. So if the virus says, you know what, it's pretty much like a game of chess. So if the virus says, okay, you're gonna do this, I'm gonna counter with this. But then the antibodies that our bodies make, they're like, you know what, fine, if you wanna do that, we'll do this. So it's a constant game of chess to kind of like and see who will prevail, and then hopefully we will prevail. So let's kind of go into, I guess, the vaccines and then what's going on. There's stuff I want to say, but I guess I won't say in this forum just because it's probably not the appropriate place. But in the state of Georgia, and these are numbers from off of Georgia's website, the Department of Health's website, regarding up as of yesterday, dealing with the numbers that have been out. So as of yesterday, there have been over 1,400 providers that have been allowed to give the vaccines. And then we kind of see the allocations here. So Pfizer has allocated Georgia over 350,000 doses, whereas Moderna has allocated 360,000 doses. So of that, Pfizer shipped out almost 74% of their allocation, and Moderna shipped out almost 82% of it. And then what we've seen so far, where the vaccine's been administered so far, of those that have been shipped, we've seen I'm sorry, it appears I muted myself by accident. And I guess what was the last thing I was heard before I was cut off?
You went through the Moderna shipping, so you were at 82%. We heard all of it except for the last
Okay. Okay, so then in Georgia, only 30% of those vaccines that have been shipped totally have been administered. So there's a lot of work to done to kind of get it out. And then I kind of looked it out. I want to say that is almost everybody in Lamar County.
No, we're all over, but Lamar County is a close by county. So Macon-Bibb is probably the most central, but you can use Lamar County as an example if you like.
Okay, yeah. So so like with Lamar County, they've been allocated and they received 975 doses of I think it's the Pfizer vaccine. So, and then that's through the health department. So, and then that kind of goes into like the vaccination plan. And then each state has something different. So I know in Ohio, we're kind of like, if they kind of start, it's like, you know what, we're gonna start at 80 years old and then work on a 5-year increments to get the vaccine out. And it's kind of like a modified version of the CDC plan. So we kind of see in Georgia now, they have 4 different plans or phases. So you have the dealing with the limited vaccine availability. And then after we get out of that phase, then it's going to go to increased vaccine availability. And then phase 3 is where the vaccine supply is widely available. And then after that is phase 4, where it's mitigation, recovery mitigation. So what do all those mean? So right now we are in phase 1, which is the limited COVID-19 vaccine availability. So the supply is expected to be limited during this initial phase. During this phase, vaccine efforts will focus on reaching defined critical populations who meet phase 1 criteria. So you'll see people who are like your healthcare workers, so like your nurses, your physicians, EMS workers, people in long-term care facilities. Those are 65 years and older, and their caregivers and law enforcement. So those are the first people in phase 1A. And then after that, it's going to go into phase 1B, where they target essential workers. So they're non-healthcare workers, but they perform jobs that are critical to the infrastructure. So those are things like public health, safety, economic and national security. And then 1C are those people or persons between age 16 and 64 with medical conditions that have increased risk for severe COVID-19 infection. So those are people with different comorbidities. And then I'm gonna let Dr. Holness, like, he can explain the different comorbidities and what they are. So as we go into phase 2, this is where the vaccine has become a little bit more available. So, and this is to kind of expand on what happened in phase 1. So it's not going to be like where it's going to, well, we're in phase 2 now, we're just going to cut off phase 1. So phase 1 is going to still happen. It's going to still go through, where all these people in phase 1, if they didn't get their chance to get vaccinated, they still have an opportunity in phase 2 to get vaccinated. And then we'll also see, then we're going to add more critical populations too, who will actually then get the vaccine. And then as we go to phase 3, this is where the supply is greater than demand with the vaccine. So, so phase 1 and phase 2 will continue operating, but then now this kind of opens up for the general population, where the vaccine can be given to anybody who kind of wants it now. And then as we go to phase 4, and then kind of phase 4 is kind of like one of those phases where it can kind of happen either through phase 1, 2, and 3. But this is kind of, okay, well, they're documenting everything, kind of seeing exactly what's going on with the vaccines. Are we having more benefit than harm, or are we having more harm than benefit? Just kind of like a documentation process. Or is there surplus? Okay, if there's a surplus, then we can return these either back to the manufacturer, or we can send these off to other areas who may not necessarily have the amount that they need. And then also then the mitigation efforts too, they kind of reduce the vulnerability, kind of like an accountability and an accounting of exactly how did the overall process, how did it go? So I know Georgia based their vaccine process on their influenza plan. So, and when they kind of modify that with use from the CDC guidelines. So I kind of went through all that to kind of say, when will you get your vaccine? I cannot really tell you, just because everything is in flux. And so we're seeing like on the news right now that even though we're in phase 1 throughout many parts of the nation, a lot of, like you're seeing a lot of healthcare workers saying, you know what, I don't want the vaccine. So if these individuals don't want the vaccine, then that might potentially then allow different phases to kind of then jump in early. So then it's like, well, if you don't want it, then let's go into these other phases so then we can get the vaccine to people who want to take it and who would need it. And then I can talk about the, what's it called? The last part was the efficacy and effectiveness of the vaccines, and then kind of some things to kind of consider. So when we hear efficacy, when we're talking about vaccines, efficacy is kind of what happened in the research trial. So vaccine efficacy is dealing with a % reduction in disease incidence in a vaccinated group compared to the unvaccinated group. So we have two groups in the trial, those who got the vaccine, those who didn't get the vaccine. And we're gonna kind of see, okay, how did the vaccine group do with it? So we see that both Pfizer and Moderna, they had over 90% efficacy. So in that group, so we're saying the vaccine efficacy is over 9%, that in the trial group, the vaccine reduced like severe illness. And then when we talk about effectiveness, this is kind of what happens in the real world. So right now we're kind of going from this, we're transitioning from efficacy to effectiveness. So from the trials to real world. So just based on the sheer function of mathematics, those percentages will go down, because in a trial, you're gonna have people who are, like you usually have healthy people, and then you also have other people, and then some, as mentioned before, there's other people that have different conditions. So it's a controlled environment. And then you kind of know exactly what everybody has. But then as we kind of then expand the vaccine out to everybody, we're introducing unknown elements. So maybe there's people who are getting the vaccine who necessarily didn't necessarily have a condition that somebody in the trial had. So I don't you shouldn't be alarmed when you hear that, oh, the effectiveness is going down. That's just the nature of numbers and nature of math. As soon as you increase the amount of people that's going to take it, we're going to have a lot of unknowns introduced into the, I guess you could say, the equation, and that's going to affect everything. So there's different things to kind of consider when, like, you're talking about vaccine effectiveness. So you have your host factors. So these are things like age, your comorbidities, were you exposed before to the virus or not, and then the time since you got the vaccination. And then we also have to look at the characteristics of the virus. Look at its mode of delivery. So it's a 2-shot system. You get a primer dose and you get a booster. And then the cool thing about this vaccine is that before vaccines were pretty much either a weakened strain of the actual virus or a dead virus. There's no part of the living virus in it. The vaccine is going to make proteins that are on the virus, so then your body kind of recognizes it. So it's kind of like, so before it's kind of like, okay, you had to encounter it directly. So it's like, okay, I'm going to do this, I'm gonna do that. But then with this, it's kind of like, okay, I'm gonna see a picture, and then I just kind of know that, all right, your body's like, oh, I see this picture, now I know who to be on the lookout for, instead of actually having to directly confront it firsthand. So it's kind of like, and I think that's pretty cool. And then also, the other thing too to consider too is matching to circulating strains. So right now we have these different strains, these different variants out with the virus. So far, they're saying that they've seen the vaccines are still effective against it. So that's also something to consider too. So with this, things to consider that both vaccines seem to reduce the risk of severe COVID disease. And I have that in bold because that's what the FDA told them to do. It's like reduce the risk of severe COVID disease. So now this is the other things that we're like considering now. And then this is kind of why social distancing and wear masks are so important, because we don't know yet if the vaccines prevent asymptomatic infection. We don't know that. And then also we don't know if vaccinated people can transmit the virus. We don't know that. And then and there's not enough data to kind of gauge the safety for pregnant people and lactating individuals. And this is also based on animal studies. So there's a lot of stuff that we still don't know about this virus. And then that kind of just puts us in the realm of, when it comes to the vaccine, since we don't know a lot of stuff about the virus, there's some stuff we don't know about the vaccine. So, and right now the vaccines are saying it will keep you from getting severely sick. They're not promising to do anything else. So just right now it's like we were tasked with the task of prevent severe illness. Right now, some studies kind of show us like, you know what, it might stop transmission. But they have to go back and look at the data because that was not the primary task. And then we can go into, I guess you could say, ethical statistics and other things like that there. And they cannot just based on, they kind of see the stuff there and can say, oh, we'll just go run with this. Like, no, they have to actually then go back and look at all the data to kind of make that decision. It's like, you know what, this vaccine can actually do all this. But right now they're saying this will reduce severe COVID disease. So some of the stuff was mentioned before between the differences between both vaccines. And then, so what makes this really important? This is to kind of get to that big H word that everybody's been talking about, herd immunity. So with effective vaccines and enough people taking effective vaccines, we can achieve herd immunity. And I guess you could kind of say we haven't seen any type of illness or disease that's been eradicated without the help of a vaccine. So we look at polio. Polio was eradicated because like vaccines came on the scene, and then enough people got the vaccine. So then that virus was able to like die and fizzle out. So this is kind of why it's kind of so important that the efficacy, like, and it's pretty much like, because you really don't see a lot of vaccines that just come out straight out the gates with an efficacy rate so high. So this is in like 90s. So we have something in the 90s that's very effective. And then if we get enough people taking it, then there's that possibility that we can get herd immunity. But as I said before, there's so much we don't know about this virus that we just can't make blanket promises exact saying this is what's going to happen. The best we can do is like, based on what we've known in the past, based on what we're doing right now, we can only speculate as what's going to happen in the future. I kind of hope that answers some of the questions with things that were asked.
Thank you so much, Andrew. We're sure you are thinking what we are in terms of, wow, so much information from our three panelists. We first want to start by thanking all of them for educating us and you know, sharing this information. I learned a great deal over this last hour, and hopefully you have as well. There are a few questions in the chat. We want to remind you, if you want to ask a question, please do send it through the chat. It's at 5:09 p.m. We always want to make sure that we're going to be mindful of your time, but some of the questions in the chat we've already answered.
So there's a myth that the vaccine will inject a nanochip into our system or embed genetic material into your DNA, genetic engineering. Basically, can you shed light about this possible myth? So,
And that could be any of
you guys
can answer.
I'll say something first, and I'll let whoever else wants to say that. If you're worried about a chip being injected into you, you need to get rid of your cell phone. Like,
good point.
If like it has so much information on, like you can do your banking on there. It's like if somebody steals your phone and gets into your, like unlocks it, that's your whole life for some people. So if you're worried about being tracked, get rid of your cell phone. That's all I have to say about that, like regarding any nanochips or stuff being injected into people.
But they're not going to inject you with this. This vaccine is not going to do
yeah, no, yes, yeah. Yes, yeah, there's none of that going on.
Dr. Reed, can you discuss about the nanoparticle that's used to,
So,
I think that's where I'm guessing that's where it came from.
yeah, and that's what I'm thinking as well. So the nano part is right. It's a nanolipid that is complex with an mRNA. So that is the genetic part. And the genetic part is against the virus. It's not something, that is going to be used for tracking. It's the genetic material of the virus to help your body mount an immune response against, the SARS CoV virus if it encounters it. So they did use nanotechnology, that's correct, but it's a nanolipid, and they basically used it as the delivery mechanism. So with every vaccination you have the genetic material, and then you have the vehicle that it needs to kind of get into your body to say, hey, build a response against me. And so in this vaccination, which I think is really nice, they used a nanolipid, well, the vehicle, the nanolipid, and the protein, which is the spike protein mRNA, as the vehicle to get it into your body. But it's not, something that's going to be used for like government tracking or genetic material in that regards. Yeah.
So that nanoparticle disappears, correct?
Yeah.
And go ahead.
Oh yeah. So the your body is able to rid itself of nanoparticles. So no nanoparticle just continues to circulate through your body.
That's
And
great.
the other thing is the mRNA that is used. So the mRNA that Dr. Reed was talking about is the technology. This is a new technology that they're using with this vaccination. It's being carried by the nanoparticle, which is butter or fat, into the cell itself. And people now are thinking that mRNA is going to be genetically in me for the rest of my life. And that's not the way it works. Basically, the body takes a picture of that mRNA, and that mRNA is discarded. So it's kind of like I'm going to somebody's house. So imagine, you're going into somebody's house, you have a copy machine, and they're basically making copies of what you give them. And that's kind of what the cell is doing. And it doesn't embed in you. It's just our body taking a picture of it and designing that protein so that we can develop an immune response. Dr. Reed, can you explain it a little better than I can? I'm just trying to give a picture.
That was really good. I think that was really good. I have a picture, a little image just to show what the vaccine, like a picture of the nanolipid. So as you can see here, you have your nanolipids, and this is really kind of what your nanoparticles would resemble, your mRNA, and it's mixed into your vaccine. So again, it's just a newer technology. And the most important thing is that we wanted to make sure that it's resistant to degradation, because we know mRNA isn't the most stable. Oh, sorry. We know it's not the most stable. So we want to make sure that we're not really giving you something that's going to degrade easily.
Okay, the next question that's up is one about President Trump had a case of COVID. He went into the hospital and they were able to give him some drugs. Can you walk us through what were some of those drugs, and is it true that there were human fetuses as a part of the ingredients for that drug?
Do you guys remember what, was that remdesivir that he got, or was that the antibody loading thing? So I think remdesivir was basically used for inpatients now. It's been used for treatment for Ebola and hepatitis C, if I remember correctly. And the concept is that it reduces the replication of the virus. I'm not a virologist, so I'm just some of the reading and things I've been doing. So Dr. Reed,
how about the hydroquin or
hydroxychloroquine?
Yeah.
I don't know whether he received that IV I think it's been stated, and he had admitted that he was taking it orally over the past, I don't know how, we still don't know how long he was taking it, whether he was taking hydroxychloroquine, but the CDC and a lot of researchers have said that that's not recommended. That's a medication that we use for treating malaria, but that's not something that's advised for treating COVID-19.
And any knowledge about human fetuses being a part of that ingredient?
I'm not aware of that. I don't know, Mr. Reed, Dr. Reed, have you guys heard of anything like that?
Nothing that hasn't, I guess that's unfounded. I guess one thing to kind of note is that the regulation process that occurs when it comes to drug development is so stringent that if there's even a hint of any wrongdoing right now, there's like fines and jail time for you. So I know a lot of people are kind of, especially minorities, like they kind of talk about what happened with Tuskegee. And it's an unfortunate thing that happened. But given how things are now, how things are set up, like that's, I would say that's pretty much virtually impossible to happen again, just because there are so many eyes on the process. So different drug makers, they have their own internal set of eyes because one, they want to avoid a lawsuit. Two, the government is looking at this too, because you can't just have something out there where you're going to start killing off your citizens. So the process is very, very regulated to the point there that like, even if you go in, like the people who even went to the trials, the amount of forms that they had to fill and the amount of constantly like checkups that they got just to make sure that everything was all right, because at the first time anything goes wrong, they stop that study and then they kind of reevaluate. So you kind of see what you see on the news where they put some of these trials on hold because they're like, you know what, we don't like what we're seeing right now. So instead of continuing and just like writing this out, we're going to stop this, look at what's going on there, and then figure out what's going on there. And then from there, we're going to either proceed or just start all over again. So that's kind of how we kind of went from, we had 120 vaccines candidates down to 3 who were able to give out.
Thank you.
Dr. Nooks, let me just say this. That's a very important point that Mr. Reed brings up. In our community, because there's been experimentation in the past, anything to do with vaccinations or anything new and novel, we as a community will be hesitant. We have PTSD with what things that have happened. Even after what Mr. Reed is talking about, you have 120 different, and Dr. Reed mentioned 120 different companies or academia and researchers, narrowed it down to 3. Even after that scrutiny, it's all transparent, it's global. We still have the paranoia of not maybe trusting government, trusting, hey, this is Bill Gates' thing and he wants to make everything mandatory. The whole idea of now we're talking about nano chips, and then we have a president who's kind of conspired with a lot of things, and then we just don't know what to believe. So this point, it's made our community even more hesitant in trusting, and it comes back down to trusting. Do I trust the CDC? Do I trust the NIH? Do I trust the health profession? Do I trust this new vaccination or the 3 vaccinations that they have out? There is a trust issue in our community, and our minority community are right in the middle of it. So you're wondering, how do you navigate with all the false things that are coming out on social media? And it makes it even more complex.
Thank you.
My next question has to do with the rollout, and I think Andrew noted the process within the state of Georgia. And the question is, how long will it take for the general population in Georgia to get vaccinated, and what are the barriers? Just as anecdotal commentary, my dad is in a long-term care facility in the state, and he's already had his first vaccination, his first shot on the 29th, and he's getting his second one and within the 21-day window on the 21st day. He's had no reactions, and in his particular facility is over 120 residents, and no one in that facility has had a reaction. Also anecdotally, I do have an uncle who's also an epidemiologist and a physician. So we just have to make sure that we're informed And the legitimacy of that information is really important as we do that process. So can one of you all answer the process? Can you just quickly say what the rollout will be or when it will approximately take place for the general population of Georgians?
So I just put a link there that I can share with everybody else later. It's kind of a general kind of where you can kind of see where your place in line, if you will. And like it breaks it down by county, like state, county, like, and then if also if you have any type of comorbidities and your age and things like that. But generally, I guess it kind of what makes it more difficult because the rollout is not where they anticipated to be. So I guess you could say right now we're like 25% of right now of like where they anticipated to be. Hopefully within the next few weeks, like things will ramp up, and then hopefully maybe for the general population, maybe we can possibly see like people getting vaccines out by summer. But if there's if other people in other phases may not necessarily want it, that might come up. Some of the things I guess we kind of have to talk about the barriers are things like access to healthcare. We have a lot of people like healthcare, like some people may not necessarily have access to healthcare. And then also one thing to kind of note in Georgia that there is a $22 fee associated with getting the vaccine. But then there's also stated too in the guidelines with Georgia that if you can't pay it, they will not deny it to you. So money will not be a factor in getting it. And then kind of think of the administrative fees kind of thing, like, so places are just getting the vaccine, but they're not getting the needles, the syringes, the alcohol, so like all the stuff there to kind of actually make, to get you the vaccine into your body. So that stuff costs money. So it's not like, oh, we're trying to get rich. If that was the case, they would like then send this off to the highest bidder. But these are like, these kind of fees are just kind of like, you know what, we kind of have to have the supply chain infrastructure in place so that everybody has a chance to get it, but then money will not be a prohibitive factor in saying to get it. So best case scenario, hopefully we'll, like Georgia can, like the common person can get it by summer, hopefully earlier, like things go real well, maybe earlier. Worst case scenario might be pushed back later. So like it's just kind of one of those things that's just kind of hard to tell because there's so many moving parts. That's just going on right now. I guess the best thing to kind of do, is to continue going on the Department of Health's website and tracking information. They've been pretty good at putting the data up there. So yeah, they even have the points there where data's up there where this is available to the public, where you can kind of see by county, if your county, how many doses your county has got, and who got those vaccines. So that's the best I can offer with that.
Excellent point.
Yeah.
In fact, if you go onto the website, I do know that at least one of our local counties, they are starting to administer this coming Wednesday to anyone 65 years of age or older. So again, like Andrew mentioned, you want to go on to the website for the Department of Public Health. You want to look at your particular county, because sometimes it can vary from county to county. But again, if some of the eligible individuals in phase 1A are not accepting the vaccine at this time, then your ability to receive the vaccine can move up. So please do check the Department of Public Health for the state of Georgia. The next question that's before
Dr. Nooks, in the VA that I'm working at is 75 years and older for now, and hopefully they'll drop down to 65 years and older as they get all the people, all the veterans over 75. I know we have a number of veterans on the line too, so.
Excellent point. So just as you can see here, one county is doing 65, the VA is doing a different age. So please do check that website. One of the questions we had was if you have already tested positive for COVID-19 or been exposed, what is the recommended time to receive the vaccine after the body has built antibodies to COVID-19? Any of the three can answer.
So I think in my reading, it may have been 90 days. what they're suggesting is that just because you've been infected and you have the antibodies, the issue is that how long will you have immune memories, what they say. How long will your immune system remember that response? So I think I saw 90 days. The others can correct me, but I thought I saw 90 days.
Yeah, 90 years, based on
Yeah,
CDC
on the
guidelines.
CDC guidelines, yeah.
Recommendation for possible reinfection is 90 days. So I know that if you test positive, let's say you test positive like today, and if you took another test and test positive again within 90 days, that will still be considered part of that first infection. But then if you test positive after 90 days, and this is after the onset of symptoms, then that'll be considered a new infection.
But like Mr. Reed had mentioned, this is still ongoing. We're still learning a lot. The vaccine is out now, and so things are changing as we speak. But they're saying in general, just because you've been infected, it still may, after a period of time, it still may be protective for you to have the vaccine.
Okay.
We did have a question about Bell's palsy, and Dr. Reed, you had mentioned this before. So can you give those statistics again about, you know, how many people were tested for Pfizer and Moderna, and how many people were you know, had that side effect of Bell's palsy? I think one of our guests, audience members, did not see that information, and I didn't.
Yes.
see
So
that statistic.
for Pfizer, 4 out of 30,000 individuals experienced that. So that's 0.001% of participants. And then for Moderna, 3 out of 43,000 patients experienced that. And so that's 0.0006% of participants.
Do you have the breakdown of the who was in which group?
Yeah. So in the Pfizer, of the 4 people that experienced the Bell's palsy, 3 of them were a part of the placebo group. So they didn't even receive the actual mRNA part. They had just received the lipid portion of it. But in Moderna, of the 3 people, 3 of them actually did. So only 1 person in Pfizer had received the vaccination and got the had gotten Bell's palsy. But for Moderna, only 3 people who had gotten the vaccination had actually gotten developed Bell's palsy. So 3 out of 43,000.
So just to clarify, can you further explain what a placebo is? I'm sure a lot of people know what it is, but they may not. So if you could explain what that is, that'd be great.
So a placebo vaccination is basically going to be just the vehicle, just the substance that you use to vaccinate, but it doesn't have any DNA in it or any RNA or anything to help your body build an immune response. So sometimes for placebo, they give people saline or something of that sort. And so in this case, someone who didn't really get the actual mRNA vaccination had just developed that side effect after getting it, while the actual vaccination is going to be the actual mRNA to help your body build an immune response.
Excellent. The final question.
Dr. Nooks,
Yes,
just
sir.
a comment. So with Bell's palsy, it is facial paralysis. It is temporary. It may last 2 weeks to 3 months to 6 months, but most of the time it's rarely permanent. So those are some things that people would want to know about Bell's palsy. So most of the time it's going to recover. You're going to recover from it. The other thing is that in medicine, and Dr. Reed and Mr. Reed mentioned also, we don't have any perfect medication. You know, vaccinations aren't perfect. So I bring up what Dr. Reed mentioned. In medicine and in health, we look at risk and benefits. Again, that's the key. Am I risking myself by not taking it more, or am I benefiting myself more? And I had done a presentation with a group, and I said, you just have to look at your risk and your benefits. Are you risking more when you go to work and you're in the health profession? maybe that's something you may want to think about. Am I risking being at home that I may have elderly parents at home that may get infected, or children that may be infected? Maybe, you know, am I concerned about my community? Am I concerned about my church or whatever? So am I at risk with morbid diseases that I may have, my COPD, my CHF, my heart disease, my obesity? So you have to weigh taking a risk or taking an educated risk, but anything you do, it's a risk. You're a risk if you don't take anything. You're a risk if you do take it. And you're trying to minimize those risks as best as possible and use the tools that God has given us and the wisdom that you mentioned, Dr. Nooks.
So we have several questions, and we don't want to belabor, but we want to quickly see if we can get some of these answered. Is there going to be forced vaccination, or is there a forced vaccination rule right now? I think the answer is no. There are no rules presently that are forced vaccinations. However, some organizations may require individuals to possibly be vaccinated, but at present date, to my knowledge, there are no forced vaccinations. Is that correct, our panelists?
No, and even with the VA and the hospital, they're not forcing us. There's still an option. I mean, they're strongly encouraging us. So, you know, if there's anybody that should be forced, you're thinking if you work in the health profession, but no, this is still not considered mandatory.
It'll always be an option for you, but you might have to not be employed there if you choose not to get vaccinated, you know, so some organizations may choose to do it in that vein.
Yeah, and even individuals with like allergies or things like that, you know, even if your hospital did have a forced vaccination policy, if you have allergic reactions to vaccinations, you'll be excused from that. So depending on where you are, there's different things. And same thing at my hospital, it's not forced right now. The flu vaccination was forced. If you didn't take it, you would be terminated. But they're not doing that for COVID.
And then, which leads us to the next question. Someone asked, are there, what do you call it? Common, the prescriptions that are out there, are there any conflicts with certain prescriptions or asthma or anything like that, that we already know that the vaccine will cause problems for individuals? Like an allergic reaction or anything like that, that have already been listed for the current vaccines that are on the market?
So is your question whether there are certain things that we could take or supplements or
are there
just
any
medications, side effects that could interact with the vaccine if we get the vaccine?
Yes.
I don't know, Dr. Reed, do you have an answer for that? Both Reeds? I'm not sure.
There was a list of certain drugs, if you're on, you should talk to your doctor about. So one thing they listed, like if you're on blood thinners, you should talk to your doctor about your vaccination before. It doesn't say not take it, but it does say talk to your doctor about any specific interactions. And I think that's what generally any medication that you're on. Before you get this vaccine, please contact your primary care physician and tell them, you know, this is what I'm on. I'm on sugar medication. I'm on blood pressure medication. You know, I have this condition. What should I do next? And they are more than equipped to advise you what you should do for your specific condition. Anyone who's experiencing anything, if you have to take some medication on a daily basis, talk to your clinician or your provider about whether or not you should, how do you approach the next steps about taking the vaccination.
All right, we know that there are a few more questions coming in. It's the 5:34 hour, and we're starting to see one or two people start to drop off. So we want to make sure that we are mindful of your time. Some of the questions that are still in the chat, some of them have been answered. For example, the question about the UK strand and the South Africa strand, that was answered earlier in Andrew Reed's presentation. This is being recorded, so we will make sure that we get it to our IT team so that they can upload it. but it sounds like we need a part 2 to this. It sounds like this is still new enough that we need a part 2, and we're willing to do a part 2 on this particular topic. So I see some head shakes.
Yes.
That part 2 is probably the best thing, because we can't get everything in one episode. So with that, we want to thank again our panelists for being on the panel and sharing all of the wonderful information with us. We know we have our pastor and first lady on the line, so we're going to yield to our pastor at this time to say a few words, to remind us about 7:15 each night, and then again to let people know we're here 4 o'clock each Saturday or each Sabbath. Please do come back. We're going to have more programs like this and more topics. So Pastor Boswell, please take it from here.
Thank you, Elder Nooks and Sister Nooks. Allison, thank you guys for putting this beautiful program together. Very informative and educational. And we do advocate for a part 2 as soon as possible. And so we just want to thank our panelists,
Yes.
Drs. Reed and Dr. Holness. And I think this was time well spent. And we do encourage you, if you still have questions, you can make sure you try to get as much information as you can as far as making a decision, a personal decision as far as whether you should take this vaccine or not. The best advice I think the doctor gave is talk to your doctor.
Yes.
And make sure you have all your questions answered. So again, we thank you so much. This was very good. We appreciate it very, very much. And I just want to recognize and give a shout out to Sister Collins, who's on Zoom today. Amen, Sister Collins. She is isn't that wonderful? Sister Collins been trying to get on the Zoom and she's here. Praise the Lord. She got on today. There may be others on, but I just saw her picture and happy to see her. Again, just want to welcome everyone to our prayer line. We have a prayer call each evening at 7:15 for 15 minutes. And we always pray for our healthcare workers, our essential workers, and our front workers every evening, except Wednesday. Every evening at 7:15 is 15 minutes, and you're welcome to dial in and give us your prayer requests. We're at Bethany SDA Adventist Church, 1550 Etna Place in Macon. And we invite you to come visit us once we start having services. We appreciate it very much. My wife is here. She may want to say something.
Hi, everybody. Some of you I have not seen in a long time. It's good to see your faces. But I tell you, all we can do at this point is stay strong and prayed up. And this too shall pass, and we will be able to come back together again as a family. So stay safe, stay strong, everybody.
Okay, so for that, for those of you who'd like to join us for Bethany Family Connect at 7:15 each evening to pray, that number, that telephone number is 508-924-3919. We're going to put that in the chat, but that number again, 508-924-3919. You can just lock it in your phone and you can dial in at 7:15. And as Pastor mentioned, it's only 15 minutes. So this time, Pastor will ask you to pray and close us out.
Okay, let's say everyone bow their heads as we pray. Lord, we are grateful for this beautiful program, this beautiful opportunity to come and learn about the vaccine. We thank you for our participants, for our panelists, and for those who work diligently to bring this program to us. We pray you bless their ministries. We pray that you bless their practices, and in all, Lord, let you receive the glory in all things. Now bless us and keep us, we pray, and bring us back again at the appointed hour. In Jesus' name, amen. 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 God bless you. Have a good night, everyone.
Thanks for joining us again. Thanks to our panelists again. Take care now.
Be safe.
Bye.
Bye.